All right, let's take a look at our independent work that was assigned from last time. And the question that we're going to take a look at right now is called doubling bags. I included the idea of using the Student E tool. And I'm hoping that if you were a little confused, you were able to access that. But let's take a look at these questions. So starting with letter A, do you think the larger sample space will change the likelihood of drawing blocks of different colors? Some of you might have thought that that would happen, but if we think about it, as we double, so if we double each color and double the bags, we have doubled the total. And I like to think about this as I think about equivalent fractions. So let's take a look at letter B and analyze this a little bit more precisely. How many are there of each color now? Well, now I notice that I made an error here, and so I'm going to go right ahead and address that error. There were 0 in this bag, and what we should have had is yellow. And the number of yellow cubes in the bag were 2. The number of blue now are 10, up from 5. The number of green is 8, and the number of red would be 4. As I move down into looking at the theoretical probability for each of these, I'm going to rewrite this. I'm going to put the probability, and then I'm going to put the parentheses around there of getting red. Now, if we think about the actual number of blocks that we have, or cubes that we have in this bag, we would have 4 out of 24 of them are red, or we could reduce that all the way down, simplify it all the way down to 1 out of 6. Green, we'd have the probability of getting green would be, so we look up here, 8 out of 24, or if we reduce that down all the way, we would have 1 over 3. Blue, we would have the probability of getting blue would be 10 out of 24, or we would reduce that down to 5 over 12. Orange, the probability of getting orange is still going to be 0 out of 24 or 12 or 10 or whatever it is. And then we need to add yellow over here. The probability of getting yellow is 2 out of 24 or 1 out of 12. And you could take that and compare it to what we had on the previous problem with our probability that had not been doubled. So now when we're taking a look at that, has the probability for each different color block changed? We can actually say no. How do our answers compare? Well, they are equivalent. And moving down to this, if we were to make 12 draws, okay, 12 draws from the combined bag, replacing the block between draws, how many times would you expect to draw out a blue block? Well, it would be the same as we had before, 5 12ths. Because even though our total now is 10 blue and 24, we simplify that probability down into the lowest possible form, and we get 5 12ths. All right. So now let's take a look at the next set of problems, starting with 1-80. And this is a problem similar to one that you may have remembered from a previous assignment. We've got Tom, and he's got his special or favorite marbles in a leather bag. And we've got 5, 4, and 3 marbles. Altogether, we have 12 total. All right, super important that we know that. If he randomly chooses one marble to give to a friend, what is the probability that it's blue? Well, again, we have 4 is the part that's blue. 12 is the total. And so there we are. We could write it as a reduced equivalent fraction as 1 out of 3. But Tom changes his mind, and he really does not want to give away blue marbles. And he's going to try to change the probability that he chooses a marble to 1/10. How many marbles that are not blue could he add to the bag? Well, if he has 12 right now, okay, and he wants the probability to be 1 out of 10, and we know that he has 4 blue right now. If I think about my giant ones, if I multiply 1 times something to get 4, that would be 4. And whatever I do to the numerator, I do to the denominator. So we'd end up with 40 total marbles. I need to do another step though. We're going to take that 40 that we need to get, and we're going to subtract what we have. So 12 is what we have. And this is our target. Do the subtraction and you get 28. So he needs to add 28 not blue marbles. So that's our answer there. And one of my favorite problems that we have, I would like to be in charge of a game at an amusement park or at a fun family night at a school. And one of the games that I could be in charge of is involving a robotic arm that randomly grabs a stuffed animal out of a large bin. We are supposed to set up the game so that the probability of a customer's grabbing a teddy bear is exactly 1/2. So how could we set up the bin? Well, I would put 1/2 teddy bears plus 1/2 other animals. Because if I have 1/2 is my probability, I want to make sure that that is represented in my fraction as I'm setting up all the animals into this little bin. What if we returned to check on the bin and found that there were only 4 teddy bears left and there were 12 other animals? So what would we have to do then? Well, if I have 12 other animals, so remember, now I have, I want to have four teddies, and I've got 12 others. I need to add enough teddy bears so that I have this equal 1. Oh my goodness, I'm going to add 8 teddy bears. And then it would be 12 teddies and 12 others. Or I could take out 8 others. And then I would have 4 teddies and 4 others. And then I'm still having my half probability set up. Okay, more fun with probability. in just a few minutes as we move into our next video for today's lesson.